Yes, thank you very much for having me to be here to give the talk, to share our actual experience about how to developing. You could say our research, actually my research basically two things. The first one is AMiner. So just as Steph mentioned that it's alternative to Google Scholar, but actually we started that efforts before Google Scholar. Okay, yeah, but of course Google Scholar is just the more famous. And also recently, actually, we developed another thing, is ChatGLM. You could say it's another alternative to ChatGPT. But this time, of course, this one is after the ChatGPT. So, I want to ask, how many of you know that ChatGLM? Great. Thank you very much. Thank you. Okay, great. Actually, this one, we started this effort actually 5 years ago, so 2019. And we basically opened all our research, here. So it is called THUDM and on the GitHub. This efforts, we basically open all the things, all the source code, all the models about how to develop the ChatGPT, you could say. Okay, but we call it ChatGPT. And also, since that time, we spin off a company, so Zhipu is here, okay. So it's a company from the Tsinghua University, so now it is almost, 700 people, 700, yeah. And also, of course, the company was valued at $2 or $3 billion US. So anyway, so this time I just want to share our actually how to develop the ChatGLM, and also our thinking about the AGI. And also Wendy actually asked me, I have to emphasize our impact to the web, not ChatGLM, actually about the AGI, to the impact of AGI to the web. So starting from that, so also I want to mention that actually some part of the ChatGLM, techniques behind the ChatGLM, I will not explain all the technical details. But if you are interested in, you can go to the IClear Keynote. So I also give a IClear Keynote this year at the beginning of this month. So over there, actually, I just discuss more about the techniques. But this time, I'm more like to talk about the impact and also the sociology or science or society or something like that. Okay, so the first question still actually, the example I want to ask is, what is the most famous web app you can keep in your mind? Okay, so what's that? So for example, like some kind of app, like some other, like a blog or something. What in your mind? What's that? Twitter? Okay, great. So anyone else? Facebook? Great. Okay. So actually in my mind is somehow this box is about the search. But anyway, I agree with you, actually Twitter, Facebook, and all the things. But I just use this as an example to see how AI actually influence the development of the different app. So if you're talking about the search engine like a Google or Bing, probably I will use this example. Yesterday I just tried this. So Perplexity. So this, I guess you know this website, Perplexity? It's an AI search engine. Okay, I tried this one. So where is the Web Science 2024 conference and who are the program chair? So I tried this. You said this is the results. So basically, Perplexity directly gave the answers. So you say, okay, the conference actually was organized in Stuttgart, and the time and the duration, and also the program chair here, and also give some kind of reference. You see, okay, this one. This one, the first reference actually is from I guess it's 4 something. That is the homepage of this conference. And the second one is that is the program chair, and also this from the first page. But I checked. Yeah, I checked. It's wrong. Yeah, I checked it. So that's what I want to say. Actually, it's not perfectly, but Perplexity really want to do something like that. Okay. So first, of course, you see here over there, they basically do some kind of traditional search, like but beyond that means that okay, actually Perplexity try to find which page are relevant to this query, but which page is not, and remove those irrelevant page, and from those relevant page, and extract some kind of relevant information, somehow like that, and directly give you the answer. So that's somehow you could say probably the web meets the AI, and maybe, I'm not sure about how many of you use that, but maybe in the future, so that would be the AI search engine. AI search engine, okay. And also, this is one example, okay. Another example, Perplexity actually is very famous in the United States, not in China, in the United States. Another example actually from China. So this is somehow like it is called timeline search engine. Okay, it is, for example, a question is how to learn Arabic from zero. And then the search engine basically search all the relevant pages on the right side and organize the pages as some kind of timelines. The first step, second step, and the third step, and the fourth step. So it is called SIGKDD.AI. Okay, so that's some other I call it AI search engine. Okay, and then recently, of course, actually OpenAI released I guess you must know that the 4.0, right? The GPT 4.0. So with that one, you can actually this example. Okay, so for example, give you like one picture, and here is 10 watermelons, right? The question is that, okay, so imagine you are a farmer, you are just a farm owner. Can you just select which one is the best one? Which one is the best? Can you see? 10. Okay, great. Some other choice? 8. Great. And what else? This is the result. So basically, GPT said watermelon line should be awarded to the managers, somehow the best. The reason is the color, somehow the color, because the color is yellow or something like that. But anyway, I just want to say, actually the new model, the large language model, and the AI actually is just not just about give us some kind of result, but it also actually influence our daily life, do some reasoning. And also, 2 weeks ago, when I was in Vienna, so I went to a restaurant. So they give me just the menu. So this is a menu. So because it is in Germany, I cannot understand. So we use our software. So we call it ChatGLM. So I just take a picture and say, okay, what's this? So they give me the Chinese translation and say that there is some kind of main menu, soup, and also some kind of, it's a bacon, right? And also dip. And I just, because I choose some kind of main dish, and I don't know what's this, bacon. Okay, so, and I just said, please explain, and they list all the things and give me the translation. And also this is a dip, and again, I just ask what's a dip, and so they just give me all the translation. So I mean, I just want to say that the AI really just influence our daily life and help us to do all the different things. So I'm trying to just define all the different data, statistics. Still, of course, like Google is still the search engine is still #1, and the second Bing. But you see that Perplexity is here. It's very, the traffic is already very large. And also, here is some other. This is the challenge. This is not a Meta, not a Facebook, okay? This is some kind of search engine Meta. In China, from China. It's a search engine. It's just for search, okay? And here is some others, okay? But you will see that I mean, the traffic is already becoming larger and larger. So, okay, until now, I want to talk about the web paradigm actually just a change. It's just a change. Okay, so why? The reason probably we have to think about is so how AI actually is changing all the different sense, and why? What's the reason? And what's the future? What's the future direction? So I guess when AI meets the web, so probably the first reason is that because originally we use the web, actually we're just trying to find some kind of you could say some kind of relevant information, right? So I use this picture. So the value of the web actually is to help us to find the targeted information. Okay, we just use the search engine and we search all the information. When the web is small, we actually hope that we can find all the relevant information, right? Okay, we can find all the information. But so far, actually the web is just huge. We don't have time to just dig out all the information. We hope that we just directly find the targeted information. And sometimes we even ignore many, you could say, relevant information. We don't want to dig out each page. We only want to have the answer. But of course, we need that some kind of correct answer, right? Okay, so if we could have some kind of you could say some good AI. If the performance is low, right? If the accuracy is low, of course, we don't want to use AI. We just want to use the search engine and find all the pages and just check one by one. But if the accuracy is high, and then we just trust them and say, okay, you just give me the answer. I get it. And of course, before, another trouble is that the hallucination. So you said, okay, the web will probably just give you some kind of random result or give you some kind of random story. But you hope that all the information can be tractable, just like the program chair, right? The actual perplexity just lists the three names, and actually they're wrong. And also, actually, before I tried the general chair. And they actually cannot give the answer. Perplexity just gives that I cannot find the general chair information. I went to the web page. I said, indeed, on the web page there is no general chair information. Yeah, but anyway, I just said actually we are still working on that. So I mean the AI, but talking about this, probably we can think about it. What is the new picture or the new roadmap of the web? So let's just think back. Before, probably the web is of course, originally the web is a link of the pages, like different hyperlink and collecting the different pages, right? At the beginning, at the very beginning. And probably 20 years ago, we are thinking like Tim Berners-Lee proposed, and also Wendy actually proposed the linked data. And so probably the web is to link some kind of semantics, right? Okay, to link some kind of semantics. And now we have the AI. The AI basically can give us some kind of give us some kind of answers. For example, just like Perplexity is actually the AI agent. They directly give us the answer just like an assistant. And also just like, for example, the watermelon counting or selection you could see, or the menu checking, such kind of different applications or something. Each one probably is just like an agent. And we are thinking about in the future, maybe the web is somehow like a linked agent. We don't need to find the web page. We just find the agent. And we search for the agent. And the agent can give us the answer. Okay. And of course, after that, maybe we could have some kind of maybe we could have the AGI, and then we can build somehow like a human society, AI society, and also human and AI society. We have no idea about what that will be, but anyway, that is some kind of thinking. And even after that, I mean, last year, when I was the Silicon Valley, I discussed with them, most of the people actually were talking about the ASI, the artificial super intelligence. I have no idea about what that will be, but anyway, that is probably some kind of like a roadmap. But the basic rule is that, okay, traditional, okay, the web is like passively invoked by the human, like a query. For example, every time we just submit a query and we say, that, okay, I want to have some kind of information. That is passively. The web, or you could say the information space is just the passively accepting some kind of query and then give you the answer. But probably in the future is like the web, because they already have some kind of intelligence. They can just help us actively, and also actively interact with us, with the human society. That's just some thinking. But underlying that is some kind of AI-based agent. The AI is the central. We have the vision agent, and we have all the different agents. Okay, so of course, before, there is a big gap between the human and the AI. You know, the AI, as a human being, basically we said, okay, we have to, like we understand the intention of each other, and then we can see something, right? But for AI, how can the AI understand the intention? And you know, so far, we actually just use a problem to just trigger the AI to give us some kind of answer. That is the big gap between us. And also the AI actually has some kind of like trouble, you see. The knowledge actually is static. Take for example, the GPT-3 as an example. Okay, GPT-3, originally, I mean, even until now, like GPT-4, the knowledge actually is limited. Because the model actually has been trained like use the existing data, not the real data, right? Okay, the information is limited, okay. And also, sometimes is unpredictable because the hallucination, right? Okay, just use this example. This is GPT-3, okay. So far, the GPT-4, they already fixed this trouble. So for example, you can ask a question. So what is the second highest mountain on Earth? So this is the answer of the GPT-3. So the text is perfect, right? The text itself, I don't mean the answer, okay? The text is perfect, okay? But actually the answer is wrong. So actually the second highest is K2. It's K2, it's not trial, right? Okay, so, and also another thing that for example, another example is who is the president of the US in 2022? Okay, so, and also GPT-3 give a wrong answer. So because the knowledge actually trained in GPT-3 is before 2022. Okay, of course, so far actually, OpenAI use some kind of like a search engine, RAG, retrieval augmented generation to fix such kind of problem. You could say to fix such kind of problem, but there are still some kind of trouble. There are still some kind of hallucination, right? Okay, another one is about the abstraction and reasoning. So this is somehow example, actually this example from a researcher from Google in 2020. So the example is something like that. Can we just teach the machine to answer such kind of question, even just use one example? Okay, the first example, okay, say there is a blue one and there is a red one, and here is the answer. Can we just teach the machine so that the machine can automatically generate these results? As a human being, we can quickly abstract this one, right? And do that very easily. Okay, so, but machine, can we do that? And the second example actually is more complicated. Okay, you say, so I give you the 3 examples. So what is the answer for the fourth one? Okay, great. So abstraction and reasonability is very high. Okay, so but can we use the GPT-4 or GPT-3 to do this? So do you think? So if you think that GPT-4, for example, can do this, raise your hand. Yes, GPT-4 can do this, right? Okay, great. Yeah, actually GPT-4, but most of others actually didn't raise their hand. I ask her again. So do you think GPT-4 can do this? Yeah, actually GPT-4 can do this. Yeah, but GPT-3, probably GPT-3 cannot do this. So such kind of reasoning and abstraction, so before such kind of large language model and AI, they don't have such kind of ability. But now, indeed, they have such kind of abstraction and reasonability. Well, again, let's think about it. So our human being, so because they originally, before they have some kind of gap between the human being and also the AI, as a human being, we actually have two brains. So system 1 and the system 2. System 1 basically is some like a hybrid matching or something like that. For example, I ask you, shall we have dinner? Probably you will say, yes, of course. So, and you answer such kind of question very fast, and probably automatically, without thinking, right? Without thinking even, okay? But system 2 actually is to answer such kind of question, where shall we have the dinner? You have to think it. Oh, so with who, right? With family, of course, home, right? But with friend, and where is come from? And shall we? Yeah, you have to think about that. That is slow and logic, and also actually is controllable. And finally, you have to use some kind of working memory and to think all the different things. So that's a system 2 to answer such kind of question. You have to use the reasoning. So actually, before the AI, to answer such kind of question, for example, where to have the dinner, so we have the symbolic AI. So that is, we actually design the different rules and also all the knowledge to do the reasoning. And also, we have the expert system, that's the second generation. And now we have the deep learning. And also, we actually, starting from these efforts, so actually around 2019, our idea is that can we just use the language model as the system 1? Because the language model around that time, remember, around that time, 2019, actually is BERT. BERT basically is the best model, right, to answer such kind of questions. Okay, for example, to generate some kind of embedding, and you can do some matching, and then give the answer. And also, we are thinking about it, can we just augment some kind of knowledge graph so that the knowledge can do some kind of reasoning? So that's a system 2. System 1 and the system 2. System 1 is to matching. For example, we generate some kind of embedding. And the system 2 to do some reasoning. So that's the idea. So actually, indeed, it works. It indeed works. So for example, to answer such kind of question, who is the director of the 2003 film, which has the same film that called Cafe in Los Angeles? So this is somehow like a complex query, right? But of course, until now, you can use the Google, or you can use the GPT-4 to easily answer such kind of question. But around that time, 2019, it's very difficult. It's very difficult with BERT and with GPT-2, because 2019, we only have GPT-2, right? They cannot answer such kind of questions. So we actually use that idea. System 1 is a large language model, and system 2 is a knowledge-driven, you could say, decision system. Okay, we published this paper in 2019 at the ACL. So it can significantly improve the performance. Like traditionally, probably 30%, 30%, we can improve to up to like 50%. Like that's really significant, right? Okay, but after about half a year, at the beginning of 2020, we found that if we increase the size, model size, and to a very huge model size, the model itself can answer such kind of question. Even better than the two systems. So I don't mean that the system 1 actually just handle all the things, but probably we have no idea about what is the boundary of the system 1. That is the first phenomenon. Another thinking actually probably come from this. Probably the whole system, the large language model itself, already incorporates some kind of like a reasoning ability. I mean, some kind of knowledge or something in the system one. I mean, large language model is not just a system one. It's probably the combination of the originally system one and also some part of the system two. So that's some kind of thinking. So this is just a traditional thinking. So the transformer, of course, come and with the transformer, we can train a very huge model, right? You see, we can train some kind of like a trillion scale model even. Okay, so that's the reason actually is that. So one thing is that the transformer actually you can build a very long context, like a 1 million context or something like that. And also the second reason actually is that, for example, the apple is a computer and the apple is a fruit. Transformer basically can build a dynamic context for each word. So it's not a static context, it's a dynamic context. And also we can train a very huge model. And then after that, actually many people use like a GPT style to train such kind of very large scale. And also recent years, also people think about it like a SSM, that's a state space model, and also the RN. Yeah, because before we actually just use RN. So, but after that, for example, like the LSTM. LSTM was a famous model, and actually people say that probably we don't need the LSTM. We just use the transformer, for example, GPT, BERT, and also Llama, and the T5 or something like that. But recently, this year, actually, the first author of the LSTM, they also proposed the XLSTM. The performance is also very good. So, I mean, this is just a different structure of the different model architectures. So we actually also propose the GLM. So GLM is also a compilation of you could say the GLM is a compilation of the BERT and also the GPT architecture. So GPT architecture basically is the autoregressive generation to generate all the following from the left, based on the left tokens, to generate the right tokens, right? Next token prediction, basically. So BERT basically is to look at both sides and to predict you could say the mask tokens. So, okay, so GLM, I mean, our proposed model, they basically still, it is an autoregressive model. So based on for example, the left tokens, predicting the next tokens, but when they're predicting the next tokens, we mask some kind of tokens, which means that we do the both things. For the masked tokens, they look at both sides. But for the following tokens, they only look at the left side. So it's somehow like a mixture style of the two things. Okay, so that's basically the GLM style idea. So that's the reason you could say you could say the GLM and also ChatGLM is just an alternative of the ChatGPT or GPT. But the most important thing is that we unlock all the secrets because we make it all the public. Just like that recent years actually we cannot do some kind of research on large language model. One reason is that we have no idea about how OpenAI actually is working on the GPT and the ChatGPT and the GPT-4 and GPT-4o. So we actually opened the base model, the GLM130B, and also that is a base model. Okay. On the top of that, we actually developed the ChatGLM, so ChatGLM130B, and also at the beginning of this year, we developed GLM4. The GLM4 basically is a comparable model to the GPT-4. So we basically have all the different models, like ChatGPT, we have the ChatGLM, and DALL-E, we have CodeView, and the Codex, we have the CodeGX, and the WebGPT, we have a WebGLM, and for GPT-4V, we have the GLM4V. So that's basically we have all the different models. We put all the research actually on the GitHub. So if you go there, you can check the different models. So we actually attracted quite a lot of stars. So for example, for the ChatGLM, we have 3 different versions. So if you combine the 3 different versions, compared to the llama, so you know the llama is famous, right? Compared to llama, we almost have the same number of stars. There's 3 different versions. The red one basically is the three version of llama, and the blue one basically is the 3 version of the ChatGLM, and the dark one, I mean the black one, actually is the Grok by the X.AI. Okay, so and this year actually GitHub released this is basically the top GitHub account with 4 generation AI reporter with at least 500 stars. You see that we actually were ranked top 5, the tier 2 DM. So we can do such kind of things. For example, give an image, just like a watermelon counting or something like that. You see that this is a picture. So what the color of the clothes of the girl whose hands are holding flowers. Let's do that step by step. So you see that the model actually can first find the flower, and then find the girl who is holding the flower, and then find the clothes, and finally give the color. So that is step by step, okay. And of course, the model actually can understand the semantics very accurately, very precisely. You see that what the color of the jean of the girl whose hand are not holding flowers. You see that, okay, so the model first defines who actually is not holding the flowers. Okay, this girl, and then find the jeans, and then find the colors. Of course, this is some kind of simple example. Actually, what we really want to do is that we can dig out to answer some kind of like a complex comprehension. So what does this mean? Before, probably you say that, okay, to understand what's in a picture, what's the objects in a picture, that's enough. Just like this. This is the example. What are showing in the photo? If the answer is a man and a chicken, that's quite enough. But actually, what we really want to answer is such kind of example. Okay, so here is some kind of figure from the line graph from the U.S. nationwide. So there are 3 lines. The first one is house price, and the second one is rent price, and the third one is the income. So you can ask any kind of question. You can ask, for example, which year has the highest growth rate of the house price? Okay, so the model first has to understand, you are asking about the house price, and matching this query to the different lines, and to say that, probably the blue one is what you want to check. And then find which year has the highest growth rate. And finally, 2008 has the highest rate. So the answer is that, the year 2008 has the highest growth rate, and for the house price, which is 150%. You said that is what we want to do. But how to do that? How to answer such kind of complex query? So we have to understand this, and also sometimes we even will have to call some kind of tools. For example, sometimes we have to program something, and sometimes we have to call a calculator, and also sometimes we will have to use some kind of tool like a function call to do something. So we have to build a whole system like the GPT 4V or GPT like 4.0. They are not just a model. The model actually can automatically it's not just a basic model. Actually, the model can call some kind of function and can use some kind of tool, and also has a very long context, and also can actually use some feedback to refine the model. So that is, we call it, you could say that it is an agent system, but we actually call it all tools because the model can automatically call the different tools. Okay. So what does this mean? I use another example to show this. With that one, with the all-tool ability, with the all-tool abilities, you can use this one. Change my phone display mode to light mode. You ask your assistant to do all the things, So the model can use, for example, screenshot to check, I want to do this, where is the setting? And then click the setting. And to show this one, And then look at this screenshot and to say, that, oh, where is the display and also the brightness? And then open this, and from this one, and click the light mode. And finally have this last one. Okay, all these things has been done by the assistant. And on the top of that, it's not just an agent, right? This actually is a paper published by I think the author is from the Stanford University last year. So it is called generative agent. So the idea is that can we use the large language model or AI to control all the agents to form a society? So the whole society actually has been developed by the AI, not by us. So each agent, so they basically, for example, in the morning, they can get up and they can walk around, have the breakfast, and go to the school, and they interact with each other. If they meet with each other, they can talk to each other and do some kind of conversation. So this is that, okay, can we just use the AI or large language model to build, everyone can build your own agent. So we have the API, and we can easily do some kind of APP. For example, we can even use some kind of large language model, use some kind of text. For example, we can give some kind of like a prompt, and then we can develop some kind of like a agent. So this is one example. So we can use this agent to just generate a picture book. So for example, for your kids, okay. So this is another example. We can use this one, for example, to post a poll or to get some kind of like the first one actually is that the first one you ask a question, can we just post a poll about which one to buy, lipstick or some other thing? You just use that sentence, that text. And the model can build a poll for you to do all the things. First, you create a new and ask a question. So what kind of question is the model should ask? And so you say, okay, the model just said which one to buy, and then generate the first item, and then the second one, and finally complete this one. Okay, so that's the first thing. And the second example, actually, you ask, where can I get a sandwich? So the model will first search, open this one and search and find the location. So actually, you can even do that by yourself. It's quite easy, okay. So now we have millions of agents. So all the agents are just in Chinese. I'm sorry for that. But this is not by us. This is by the user. The user actually uses that one to develop millions of agents. So that is what I mentioned. So the web probably is already a linked agent. It's not just a web. It's actually an AI-based agent. So if you go there, actually, we are not ready to find the page. We are not ready to search something. We are just find the best assistant, so that the assistant can help us find the right answer. Okay. And also, we are thinking about the agent, you could say, the society. So because the left one, you could say, actually, this picture is from this paper. The left one is the individual level. Okay, it's more like an agent, because each agent basically is an AI-based or large language model-based agent. Okay, so each agent can help us, or it can automatically do something. But the right side is more like an environment. Okay, the agent can interact with each other. Okay, we have an environment. Okay, and also the agent probably interact with even human being. Okay, we have you could say, a human and also AI society. So how can we do that? We should do something beyond you could say, the auto system. Originally, we already have the auto system. It's not just a large language model. In the middle, it's a large language model, okay? And if the model can use tool, can use different function, and also can program, can interact with the different society, and also can use the knowledge graph, so the model itself is already a system. But if we continue the efforts, we add something like a memory, and also we help the model to have some kind of self-reflection, we can even have some kind of agent operating system. Okay, so this is the idea of the agent operating system. And the basic idea is that the CPU is a large language model. Okay, the CPU is a large language model. And we could have the backbone, and we could have all the different like a knowledge base. It's somehow like the disk, and also long context. It's somehow like a memory. And also we have the input and also output, and also we have the different kernel services. So we have the whole agent system. And even beyond that, actually, it's not just a virtual space. We could have the embodied AI, and also with the vision understanding, we could have the more kernel services. So that the agent operating system actually can interact with the environment, all the environment. So that's basically our thinking about this. But of course, actually, this is there's a long way to go. It's a big picture, and we are thinking about how to develop the future, for example, how to develop the AI and for the web. And also, we are working on the AI for the web. And also, the most important thing is that we are thinking the web probably is not just a linked of page, linked of the data. It's more like a linked of agent. And of course, we are thinking about the future society. What will be the future society? And what will be the ASI? But anyway, this is a long way to go. We are just working on this. So if you're interested, you can go to my homepage to check more paper about that. So again, this is a big effort by a big team. So I have to say thanks to many collaborators from Tsinghua and also the company Zhipu AI. So if you're interested, welcome to join us. Okay, thank you.